All right, one final topic to discuss before we make the concluding remarks for this lecture. We want to talk about polymorphic return values. Let's just see one example here. Again, let's say we declare this polymorphic collection here. Okay, static type for each member will be students. And now let's say we still got this very generous parameter over here to be the top of the hierarchy. And let's say we talk about a query. That's a new bit we are introducing. So get students, depending on where the position is going to return statically some student objects. So this is a return type over here. And then we say number one, I should be a valid position as a precondition. And now result is assigned to SSI. So now should this line compile? So that's a question you want to answer for understanding this video here. Let's illustrate this quickly. Only focus on, for now, this line over here. Only focus on this line over here. Okay. Actually, to be more precise, look at this line here, and also this line over here. And also, you want to look at this line here. So these are all the relevant lines you need to in order to judge. So should this line compile? First of all, you want to look at what's the static type of SSI. According to the declaration over here, it should be students. And also, what will be the static type for the result? Static type. Okay, as we mentioned before in your introductory tutorial, implicitly, remember implicitly, you don't need to write it. We declare the result, the reserved keyword, to be of type, whatever the return type it is, students. That's implicit. So that means the static type for result is simply just students. Okay, so now is students over here a descendant class of students so that it can fulfill its expectation? Yes, it is. So that means this should be a check. Okay, there's a very quick mention about this. So now the follow-up question for you would be, what would be the possible dynamic types of result? So now dynamically, what can be the return value that's actually from this particular query over here? Okay, so now it could be, well, since it's polymorphic, as the title of the lecture suggests, so basically you want to know that dynamic type over here. Think about the students over here is the static type for the return value. So now dynamically it can either be, given that the collection is polymorphic, it can either be students, resident students, or non-resident students. All the descendant classes of students, basically. Okay, so now all the descendant classes of students. That's the answer. Okay, so now let's see exactly what's going to happen at the runtime. So if you look back to the slides, we got one more example over here, and you can also see the description, which we already explained in the iPad. So now this particular test case is built on top of what we said previously about how we can build polymorphic collection. So I'm going to talk about just the new bits over here about getting the return value. Let's take a look. Okay. So now for this part over here, let me just, I don't need to waste your time by repeating the details. But for this part over here, this is just about how you can set up the polymorphic collection as we explained from the previous video. Okay. In that case, what you will get is you're going to get element 1 for the students array is going to point to some different dynamic type than element number 2, which dynamically points to a non-resident students object, right? That's exactly the polymorphic nature of the array. So now let's focus on the two lines that's new for this particular part. So let's now first of all look at, you can see we're calling tuition and tuition over here, right? Apparently it's going to be 750, 250. So somehow we are really calling this versus this on the tuition, right? But how does this happen? So that has to do with the polymorphic return value from the get students. Let's take a look. So now for get students 1 versus get students 2. So these are the two different context objects that we want to decipher. Okay, let's say for the first one over here. So when we try to say get students 1, so what we will do is we'll actually say, so of course implicitly there may be something you spotted. So there should be SMS dot and also SMS dot get student. Okay, just to there's a slight typo from the slides. Okay, so now when we say get students 1, so we're calling this get students over here, and when we say 1, so what you return is SS over here, say 1. That's what you're returning, right? So now SS1 is going to return this particular object over here, So now that means dynamically this object here is going to be of type resident students. So again, you can do the attach check very quickly. I'll just write down one example for you. You can say attached, and then you can say rs, and the return expression over here is here. So let's say get students, to be more precise, sms dot get students. I'll just say get students, and then at position 1. So now can you cast that, if that cast is possible, as let's say rs student number 1. Okay, and this expression over here is going to be true. And you can also try the various example as we did previously. Remember the cast over here, we try the different combination, either rs, nrs, or maybe student. That's something you can try. Okay, and let's now move on. Okay, with the example. So now dynamically, because this is really a resident student, so when you say get tuition, it's going to call the version that's defined on the resident student, which is going to apply the premium rates. On the other hand, when you call this one here getting 2, so that means over here you're going to get SS at position 2. That's what you're going to get. And that one there dynamically is really a non-resident student's objects. In that case, when you call tuition, it's going to call the version that's defined on the non-resident student, which will apply the discount rate. So that's why you got 250. Okay, so that's about the polymorphic return value, which is very straightforward. If as long as you can understand implicitly, we're really doing this particular declaration for the result, and also when you do the assignment over here, you're really doing polymorphic assignments. Okay, so all the rules about substitutions still apply. Okay, so that's about the end of this final topic for this lecture over here. I would like to just give you some concluding remarks, and let's go back to the slides. Okay, so this example about polymorphic return value have been discussed on the iPad thoroughly, so you can just go over that just to confirm your understanding. So concluding remarks for this lecture here. Oh, before I get there, so notice that there is a handout actually for you to really look at. Okay, let me just show it to you. So if you go to lectures page, you can see there is a written notes over here that's created for this semester over here. So that one is really about how you can basically, you can think about it more like a written summary of everything we have seen so far in this lecture. So you can look at that notes, and then that will definitely help you get prepared for your quiz or also exam. And of course, most important of all, is going to help your understanding. Okay, so let's now talk about some concluding remarks, and then we'll be done. So whenever you are trying to declare an attribute of certain static type, so what should be the design principle for you to decide? Let's say T somehow exists in some inheritance hierarchy. So here's a guiding principle. You want to choose the static type T, which will accumulate all the features you can predict or you can imagine that eventually you want to call on A over here. So that's something that'll be up to your decision. So let me give you some example over here. For example, you will declare S to be of type students if you believe the only features you want to call will be within the expectation of a student object, which means it does not include premium rates or discount rate, which means you never want to say S.premium rates. Otherwise, you need a cast. So let the dynamic binding to determine at the runtime which version of the tuition it will be called, right? So remember the add students feature that we declare in the student management system class. So we can create a polymorphic collection, in which case when we run a loop, and then member number 1 in the array could be of dynamic type resident student, in which case it's going to call the corresponding version. Okay. So now, however, if you realize once you declare S to be of static type students, you always have to do such casting using the check or the if statement. In that case, that might give you some reflection to say maybe you should have declared S to be of type resident student in the first place. So that would be some like an iterative process of reflecting on your design that you want to undergo. Okay, so that will be the first design principle, and then the same principle applies to polymorphic parameters and also polymorphic return values. Okay, you really want to think about this particular slide. So it's a guiding principle. You want to accumulate your experience on doing this. Okay, number 2, static type versus dynamic type. Which one should you consider? Okay, it's a summary. So whether or not an OOP code compiles only depends on the static type. Okay, you don't worry about dynamic type when your only concern is about compilation. Because inferring the dynamic type, as we said before, is an A+ challenge, which is impossible, right? It's definitely an undecidable problem for you to keep track of the dynamic type automatically in general. So compiler wouldn't do that for you. Okay, so now the behavior for Ivor code being executed at runtime. So now, for example, which version of the method or routine is going to be called, it depends on the dynamic type, well, according to dynamic binding. Or whether, when you try to do a cast, whether an assertion error is going to occur, they all depend on the dynamic type over here, as we said before. So these are the two principles for you to remember, okay? You want to know which one you're trying to judge. If you're only judging about compilation, only concern about static types. If you have to judge about the runtime behavior, then you may have to consider both, especially the dynamic types. Okay, so the best practice is really to visualize the objects, which I have been doing to really show you. So you want to draw object boxes and also using arrows to really keep track of where the new dynamic types have been changed to. Okay. Okay, so finally, so this will be a summary of all the type checking rules that you can look into. So I got a table over here. For example, you can see over here, whenever you have a variable assignment, what does it really mean that this line of code should compile? That means the static type for y should be descending class of the static type of x. So this one summarizes exactly what we said before. You can see others as well. In the case of feature call, in the case of assigning a return value to something else, and also when you're trying to do some cast over here. So this one really summarizes everything you need. But notice that because we said that every cast will just compile automatically. However, what's really important for you to realize is, in order to know if there's any runtime assertion error, you have to see whether the cast type is actually along the ancestor path of the dynamic type. So this one, for this concern, you have to consider dynamic type as we illustrated before. Okay, so that's about everything for this lecture here, and that's really the end of our review for inheritance. It's been a very large lecture here, so now this week please pay attention to every detail about the review. If there's something new that's being introduced to you, you want to really digest. And then later on, we still have the generics not covered just yet. I'm going to move the generics discussion to next week for the first part. However, also we'll start talking about other design patterns which will heavily rely on the knowledge that we have just reviewed about inheritance this week. So study properly for this lecture here, and then I will talk about more design patterns later.